Hello guys, welcome back to my channel. So today we're going to continue from where we left in the previous video. What we did, we enabled OSPF running on these two routers, and we were able to test that OSPF was actually working. But what happened is that by default, there was an election, OSPF election, between these two routers, and one of them became the DR, which is designated router, and then the other one was the backup the designated router. But we didn't follow the process. So if what I mean is, if we're going to, let's say, if we're going to open this, we're going to the CLI. Going to the CLI. If I check on R1, I do show IP okay, so we see that router 2 has a router ID of 0.0.0.2, and it's the backup designated router. We do the same thing for or do the same thing on R2. We're going to see that the DR is router 1. Okay, but issue is that the priority here is actually lower than the priority on the priority here is lower. So in reality, router 2 was supposed to be the DR. Okay, but right now router 2 is a BDR. So if you want to see who's the BDR, when you do show IP OSPF enable on router 2, what you see here, okay, this is the DR, which is router 1. So what we're going to do today is going to want to force router 2 to be the DR. Okay, why? Because we know that router 2 has a higher priority, a higher router ID, and also we're going to force router 2 to have a higher priority as well. Okay, so two things: the router ID is higher, then the priority is higher on router 2. So we're going to do that, and then we're going to force router 2 to be the DR instead of the BDR. So that's the first thing we're going to do. And then the second thing we're going to do in this video is to make sure that these both routers are actually fully connected to the internet. Because if we check on router 1, even on router 2, if I do ping 8.8.8.8, okay, ping is working. But if I do ping, let's say cisco.com, okay, that one is not working. And if I'm checking show IP route, okay, we see there's a default route here to the internet. But even though we have a default route, we still cannot go in. So we'll be able to solve that in this video. And for this one as well, we can ping 8.8.8.8. Okay, even ping is not working, so we're going to be able to resolve all of that today, right? So the first thing we have to let's see how we can manipulate the election process in the OSPF. All right, so for that, we're going to do, if we do show IP on R1, if we do show IP OSPF interface 0/1, this is the interface that's participating in the OSPF, okay, besides the loopback. So if we check this interface, you see this interface is it tells us who is the designated router. Okay, R1 is the designated router, DR with a priority of 1. We don't want that. Also, we see that R1 has a priority of 1. Okay, what we're going to do right now, we do the same thing on R2. Show IP interface 0/1. Okay, we'll do the same thing on R1. We're going to see he's a backup designated router. Priority is 2. Priority is 1. Okay, so there's a tie on the priority, and also the router ID is 2. So technically speaking, from concept, he should be the DR, but he's a backup. So we're going to force that. So to force that, we're going to leave the router ID as it is. It's already high. So the only thing we're going to want to manipulate right now is the priority, okay? And also we have to shut down the interface after that, just to, you know. So anyway, so let's go into the interface gig 01 of router 2. Interface 0/1, okay? And then we say IP OSPF priority. So we're going to give a priority of 10, okay? We're going to give a priority of 10, and then we're going to say router OSPF 1, process 1, and then we're going to shut it down. We're going to shut down the OSPF process, so that right now there's no, the OSPF process is only happening on router 1. We're going to shut that down as well. We're going to get configure terminal, router OSPF 1. So we're going to shut down. So now OSPF is running neither on router 1 nor router 2. So when we're going to enable OSPF on both routers, we're going to make sure that both of them are running on OSPF before the 40-second timeout. And in that way, there's going to be a fair election between the two routers. Okay, and if there's a fair election, router 2 should be the DR and not the BDR. Okay, so let me do, if I do show IP, just to show that OSPF is not running. Okay, so IP OSPF neighbors, you see there's no do show IP OSPF neighbor. Okay, right now we see there's no neighbors running either on router 1 or router 2. Okay, we see there's no show IP OSPF neighbor. Okay, so right now there's no OSPF running both routers, so we're going to enable. Okay, I'm going to do this. I'm going to do not sure. Okay, I'm going to do the same thing here. Not shut. Okay, so I'm going to do not shut, okay, both of them at the same time. Okay, not shut here, not shut here. So now let's do show IP OSPF neighbor. We're going to do that several times. Okay, so right now the process is still in two-way. There's the different processes, the different stages before the OSPF is fully established between the two neighbors. So it's still in two-way. The state is two-way. We're checking on router 1. We should basically be seeing the same thing on router 2. So we check on 2. So these are the election is going. So now it moved from two-way to X start. Now there's a full neighbor, full adjacency established between the two of them. So if I do right now, if I do on R1, if I do show IP OSPF neighbor. Okay, so you see the priority is 10 on router 2, and router 2 is a DR. Okay, so we successfully made router 2 as our DR, and router 1 is supposed to be BDR. So how do we know that? We can actually check it right now. I want it to show IP OSPF interface gig 0/1. So we see its priorities remains 1, and it became the backup designated router. Okay, so if I do show IP route OSPF, okay, so we see from router 1 we can reach router 2. Okay, so if we do a ping 2.2.2.2, and we source from loopback 0. Okay, so our ping is working. Tested that yesterday, it's working. So basically our OSPF is re-established with the DRB router 2 after we force it down. Okay, so right now the next thing I want to show you is how we connect these two routers, our network, to the internet. Like if you check on the diagram, we should be connecting to the internet. Okay, we should be able to ping Google DNS, and we should also be able to if we ping the cisco.com, it should be resolved on our router. So, but we have to find out if it's not resolved. We have to fix that. Okay, so how do we do it? Let's go on router 1 first. So if I do I think I tested that before. If I do a ping to 8.8.8.8, which is actually Google DNS on the internet, ping is working. So if I ping google.com, okay, that's not working. Why is not working? It's not working. If I do the reason it's not working is because we don't have domain name resolution enabled on our route. Okay, so but since we have the default route, if I do show IP route, okay, the reason we're able to ping Google is because we have a default route to the internet. Okay, we have a default route, but we cannot ping the google.com or even cisco.com because we don't have the domain DNS lookup enabled on our R1. Okay, so we're going to go into configuration. So terminal, we just do IP main lookup. Okay. Now if we do the same thing again, we do ping cisco.com. Okay, now it's pinging. Okay, it's pinging because it's now because the error we had before, now that error is gone. We can able to resolve cisco.com. How about R2? So let's go to R2. Let's do ping 8.8.8.8. Okay, that ping is failing. One of the things that we have to look first, okay, is how is R2 even supposed to know how to go to internet? It doesn't have a default route. We do show IP route. Okay, it doesn't have a default route. It has only the dynamic routes. It doesn't have any default route. So in OSPF, there's if you have like a router 1 has access to the internet. Okay, router 1, router 2 are running OSPF, and router 1 has access to the internet. You can actually configure this router 1. You add a statement on OSPF, the default information originate. That way you're basically telling router 2 also running OSPF that if you want to go internet, you can go through me. So let's do that on our router 1 and see if we have a default route on router 2. So let's go on router 1, do configure terminal, because router 1 already has a default route to the internet, but router 2 doesn't have. So router process 1. Okay, if I do default information originate. Okay, do this, save. Let's go back to router 2 and see if router 2 has a default route. Show IP route. Okay, now router 2 just got a default route. Okay, it's an E2 route, which is a OSPF external route. Okay, so which means if we try to ping 8.8.8.8, that one should work. Okay, now it's working. How about pinging to cisco.com from R2? Let's try that. We do ping to, let's say, cisco.com from R2. Okay, why it's not pinging is the same thing like we saw on R1, which means the cisco.com is not resolved. Okay, R2 doesn't know what that means. Okay, we have to add that statement IP domain lookup. Okay, domain lookup, we need to add that on the router 2 as well. So figure terminal IP domain. Okay, so let's try it again. Ping cisco.com. Okay, so what are we getting? Okay, not recognized. So what we're getting in R2 now is a second thing that we need to fix. Okay, the first thing was it didn't know how to, it didn't know what is cisco.com, so we had to add that statement IP domain lookup. That's good. The second thing is it says cisco.com, but it doesn't know how to translate it. So we need to add on R2 the DNS server. Okay, we can add a Google DNS server, and that way it should work. So which means I need to go to your terminal, the IP. Okay, so it's going to be IP name server. Okay, so I'm going to give the name server on the internet. Okay, so it can get to the internet, but it doesn't know who is resolving those DNS name URL. I'm going to give a URL name server like 8.8. Or even I can give a different one. I can give a Cloudflare. I can give 1.1.1.1. Okay. So we're going to give just one. I'll go back there. I'm going to try it again. Save the configuration. So we're going to ping cisco.com. Okay, right now it works. Okay, so now on R2, both R2 and R1, they're able to get to the internet. Okay, so what did we do? Just a little bit of a recap. So what we did is we first of all make sure that the domain names, because the R1 was already able to ping 8.8.8, but it could not resolve cisco.com. So we added IP domain lookup on R1, and then but for R2 it could neither ping 8.8.8 nor it could even resolve this. So there were three things that we had to do on R2. So, but before doing that, we had to make sure that R2 knows R1 as its default gateway to the internet. We added the OSPF default information originate on R1. That way, a default route is added on R2. And then on R2, we made sure that the R2 was able to resolve DNS names. So we added IP domain lookup. Okay. Now, and also now the added IP domain lookup, but it doesn't know who is resolving on the internet. Okay, those DNS names. We added the name server, which is 8.8.8 on 1.1.1.1. Okay, so I didn't should. But anyways, so now R2 and R1 they're able to go to the internet. Okay, as we can see here. So I'm going to stop this video here, and in the next video, right now we see OSPF between two routers. Okay, so we're seeing election between two routers. We see DR and the BDR. We want to expand this further. Okay, we want to add 3 or 4 more routers. That way we're going to see we're going to see DR, we're going to see BDR, we're going to see routers that don't participate in OSPF and how they interact when things go wrong. Okay, and also what I wanted to let you know is that every election is per segment. So this is a segment right here. Okay, so this segment is not going to participate in an election on another segment. That's how OSPF works. So I'm going to add in the next video, I'm going to add more routers. And those routers are going to be in their own segment. Okay, so that election there is going to be completely different from the election here. Okay, but at least it's going to expand our knowledge into how OSPF works when there are 2 more routers. There's a BDR, DR, and the order. Okay, the order is like any router that doesn't participate in OSPF and within the same segment. So thanks so much for listening, and this is the end of this video, and talk to you in the next video.